Hello, everybody. We're on the next session. I think we have some issues with my audio. Mason, can you hear me? No. Okay. Well, anyway, so Mason is from Texas, and he's going to be in charge of telling us what synthetic data is. And without further ado, the floor is yours.
Okay, well, I guess that means we're live. Unfortunately, I could not hear the moderators, so I guess here we're going to go. Hello, everyone. My name is Mason Egger, and I am the lead developer advocate at a company called Gretel. And today, the title of my talk is I Can't Believe It's Not Real Data, an Introduction to Synthetic Data. Super excited to be here, so let's go ahead and get this presentation going. So the first thing I want to do is let's set the stage a little bit. Imagine that maybe, say, you're a developer working on a web application. I personally like the Django framework. That's my Python web framework of choice. So let's say we're working on a Django application that manages students in a classroom. So we're building this application, messing around with everything. And then now it is time to test. So now it's time for us to run some tests, make sure our code is actually working. But for some reason, we can't access the production database for security reasons. I mean, more often than not, they don't let us just tie into the prod database whenever we want to test our code. We have to kind of create our own sample fixtures and stuff like that. And it's even more complicated in this situation because FERPA data, which is student data, at least in the United States, is protected by law. So by law, we're not allowed to have access to this data. So we don't really get access to be able to test on data that looks like the data that we're trying to write an application for. So we have to test with the database with only a handful of records, something that we create ourselves. And unfortunately, because of this, because we weren't able to foresee all of the problems or know what's going on, an edge case has slipped through that wasn't represented in the test database. And we have, problems, crashes in production, bugs, all sorts of things. Another example of this would be, say you're a data scientist and you're trying to train a new model on something. In particular, let's say you pretend like you work for a healthcare profession or at a hospital, and you're trying to predict a rare disease. You have data on symptoms, and you're trying to predict, does this patient exhibit the symptoms of this disease? You're trying to predict if they have it. So you start looking for relevant data sets, but then you find out that you don't really have enough of the data that you need. You can find some, but you don't have enough to actually be able to accurately train a model. However, you're still trying to get this done, so you have to train this model with this limited data set. It's all you have. What that ends up leading to is your model is unsuccessful due to the size of the data. You just didn't have enough data to go through with it. The model isn't very representative. It's not accurately predicting stuff. So you don't really have much more you can do. You've kind of hit a dead end. But wait, someone in another hospital has a similar data set that you think might work. They have a whole set list of this, and they're willing to share it with you. But as soon as it starts going into it, you should look into it. You can't get access to it because it has personally identifiable information in the data, and there's laws against giving this to each other. And what originally we were hoping to be able to accomplish, kind of got dashed because of just policies and laws in the way of stopping you from being able to share this data. So what I illustrated in those previous two slides are some common data challenges that both application developers, data scientists, machine learning engineers, AI engineers, all of these people seem to run into. And that is basically access to usable testing data. So not being able to have access to usable data is a very big problem. The chart here on the slide shows that whenever a new data scientist is trying to build out and productionize a machine learning model or a model, data science model, 35% of all of that time is spent in this data gathering stage where you're going out and you're gathering data and you're just trying to get enough relevant data so you can actually build something. And as you can see, it's the largest section in all of the sections: model building, productionizing, creating the visualizations, insights. All of the other tasks don't even compare to the data gathering stage. And so you're unable to access this usable data, and it's usually inaccessible due to PII. So having access to data is a real challenge. You have the other challenge that we saw, which was limited data sets. Lack of quality data can affect the model training results. If you don't have enough of this data, how can you train your model on it? How can you do anything with it? So not having enough of it really does limit you and affects your results. It could even be prohibitively expensive or even impossible to collect more of this data. So you're kind of stuck here, not really knowing what to do with it. And then we have biased data, which we didn't really cover in the examples, but we'll talk about later in this presentation, where data can be skewed towards representation of subjects in a different data set. So there's just bias in our data, and we have to figure out, how do we solve this problem? Well, a solution to all of these issues is synthetic data. And you may be wondering, well, what is synthetic data? I've never really heard of it. And up until a couple of months ago, I had never heard of it either. Synthetic data is artificially annotated information that is generated by computer algorithms or simulations commonly used as an alternative to real-world data. So that's a really fancy way of saying that we use computers to take a data set and then generate more data that looks like it. Then the magic happens and it becomes really interesting. So your first thought will be, well, isn't that just fake data? And that was my first reaction too. And in reality, no, synthetic data is very different from fake or mock data. You may be thinking of the Faker library when you think of this, where you just give it a schema and it spits out data. Fake or mock data may not be representative. Fake or mock data is generated purely at random. So you're asking the random number generator in your computer to give you something. Those relationships between the data, maybe you have someone's name and then like their street address and then their street and then their city and maybe county. That data is completely artificial and it has no relevance to each other. Those might not even be real addresses. Fake or mock data can also be too clean. It gives you exactly what you want, which is great. But as those of us, if you write applications or you've built data science models, that data doesn't come in perfect and clean and always fits into your application. Sometimes there's weird things that people have inputted. Sometimes there's weird things you have to do to correct the data. So it can be too clean and just not representative of what you're actually going to see in production. Synthetic data, on the other hand, is great for generating data, and it's generated from existing data. So you basically use synthetic data and you take your existing data and you generate more. It will look and behave like the initial data set. So this initial data, so what you have is you take it and you feed it through, and it will be representative of the data set. And it can be nearly as representative of the data set. So if there are correlations in the data, this is especially relevant for data scientists and machine learning engineers. You can take this data and then you can generate more of it, and it can be, not always necessarily will be, but we have cool tools to make sure it is, but it will be representative and true to the original data set. So today we're going to talk about synthetic data, all the cool stuff I know about it now. We're going to talk about 3 benefits of synthetic data. What I view as the top 3 benefits and the top 3 reasons why you should be looking into synthetic data for solving some of your problems. The first one is make private data accessible and safely shareable. This is a big one. Sharing data is very difficult right now. And if we could be able to share data without the worry of leaking information, it would be, imagine what we could do. Generating more samples with limited data and just, don't have enough, create more that is equivalent to what you have. And then reducing bias in machine learning data sets. This is actually a really cool one. I'm going to show you, talk to you about an example, about a case study where this is, and I'll even point you to the Jupyter Notebook where we were able to do this. So let's talk about the first one, making private data accessible and shareable. So data often contains PII, which is known as personally identifiable information, making it very risky, or in some countries illegal, for developers to be able to access this data because we have to protect people's privacy. And let's be honest, developers, data scientists, we don't want your personal information. Nobody really wants to have that in there. It adds more liability on them. What they want is the correlations between the data. They want to know, this person did this and this happened and stuff. We don't care whose name or whose credit card number is in the data. So we don't want it already. When you generate synthetic data, you can use it to create statistically similar data while removing the PII. So this will allow you to share your data not only within the company, but externally as well. So you can take a data set, say it's full of personally identifiable information, and you generate a synthetic data set on it. This synthetic data will have all of the correlations and all of the statistical equivalencies, but all of the PII will be completely fake and made up, and it doesn't matter. But it will still have those core competencies to it, which makes it much more valuable than fake data, because you can take this data set, say you want to share it with You're training a model and you want to share this data set with your colleague at another company, but you can't because it has company PII in it. You generate the synthetic data set. Now the PII is protected, and now you can share it with another person at another company, and now they can basically take your model and get the same or different results as you, but you never had to leak company data. It's all quote unquote fake. It's not fake, it's synthetic. So that's the first really cool thing you can do with it. And I just can't wait to see all the cool things we're going to be able to do when we can share data, like when we've broken down that wall of data barriers. The next really cool thing you can do with synthetic data is you can augment small data sets. So not having enough data is a serious bottleneck. It's very difficult sometimes to get data, and in some places it's expensive. It's very hard. It may even be impossible if the situation you were waiting on or the situation you were observing is no longer happening. This can happen. So synthetic data allows you to generate an unlimited amount of data based on a relatively small data set. So if you have a small data set, let's say a small data set of heart disease patient data, and you only have, say 1,000 records, what you can do is you can take this and you can just generate as much of it as you want. Now, it will be equivalent to that original data set. So if your data set is massively biased in one way or the other, you can, basically create more of a bias with it. So you have to be aware of what your data set is doing. But you can take this, and if you think you have a good data set, you can generate as much synthetic data as you want, making it much easier for you to be able to train your data science models, machine learning models. This is especially prevalent in the public sector, or any sector really, where poor data practices, such as storing your data in PDFs or unreadable formats, can cause for an abundance of inaccessible data, meaning you won't have access to it, or even if there is data, you're not able to, ingest it programmatically. The third and other really cool thing I like about synthetic data is its ability to reduce bias in data sets. So biased data is a pretty big problem. In the best case of scenarios, it leads to inaccurate models, unfair results. In the worst case scenarios, it's actively causing harm to people. And, we don't want, as software engineers, we don't want to cause people harm with the decisions that we have to make. So being able to reduce bias in data sets with synthetic data is, in my opinion, a groundbreaking thing that you can do. If you can identify the bias in your data set, you can then use synthetic data to augment the data set and debias it essentially by unskewering the data in one direction or another. The really cool example that I have to share with you here, and these slides are on my website, by the way, so there's going to be links in these. It's at mason.dev, and you can look these up and pull them up really quickly. I'll also share them with the organizers after the fact. But this blog that we have here talks about reducing AI bias with synthetic data in heart disease prediction models. So in this blog, we talk about taking a data set where the data was 68% male and 32% female at it, so a 2-to-1 ratio of male data to female data when predicting heart disease. What we were able to do is we were able to take this data set, identify that it's skewed heavily towards the male population. We can then use this to augment and generate more female data to balance the data set. So the data set became 50-50 instead of 68-32. And what it was able to do is we were able to increase the accuracy of the model from 88.5% to 96.7% in being able to predict heart disease. And that's not just in, we just got more ability to predict it in females or in women. That is true. 6.17% more females were accurately diagnosed with heart disease. But what was really interesting is that the prediction model for males with heart disease also went up because when you remove the bias, it's now balanced and the model wasn't guessing. So it was able to figure it out. So not only did balancing it, increase the prediction rate for females, it also helped increase the prediction rate for males as well. So reducing bias in data sets, really, really cool superpower of synthetic data that I really enjoy. So then you may be going to ask, well, is synthetic data accurate? These are all questions that I have, by the way. I've recently joined Gretel and we're learning about synthetic data. And all the questions in this slide deck are the questions that I had whenever I joined the company or was deciding to join the company. So is synthetic data accurate? Actually, yes. The short answer is yes. The long answer is, unlike fake data, synthetic data is nearly as accurate as the real data. And in some cases, there's improved accuracy. You can check out this blog if you want to know about it, more about that. But augmenting a training set with synthetic data had a mean machine learning accuracy less than 1% of the real world equivalent. So yes, synthetic data can be nearly as accurate. Now, it can also not be accurate. Well, how do you tell the difference? Well, there's a tool that we have at Gretel that helps you determine your synthetic data, what we call the synthetic data quality score, but I'm not going to cover that right now. The thing is, there are tools out there to help you determine quality of synthetic data. So you would generate the data, determine the quality, or read a report from the program that creates the quality, or creates the synthetic data and then gives you a quality report, and then you'd be able to determine from there. So I know I'm over here talking about, oh, this is the greatest thing ever, and it sounds like I'm selling you, something that's just like that can do no wrong, and that's not necessarily true. Like with all things, there are downsides, and there are downsides to synthetic data, and I'd like to point some of them out currently. Unfortunately, because of highly dimensional data sets with hundreds of thousands of columns, can be very compute intensive. So generating, the way that synthetic data is generated is basically by training a model and then by retraining it on your data and generating the data. So we have pre-trained models that we use here at Gretel to train your data, that you train your data against, and then you get more synthetic data. So if your data is very, very large, it becomes very compute intensive, requires GPUs, all sorts of things. Synthesizing relational databases can still require some manual configuration. We're making strides in this every day, but being able to maintain those inner column or inner table relations, you'll need to do a little bit of manual configuration. Some privacy preserving technologies, such as differential privacy, require very large amounts of data to provide strong privacy guarantees without degrading its accuracy. So it's not necessarily appropriate for all data sets. And then synthetic data just takes time and effort to generate. It's not, it takes time to train these models and do it. Now, they've gotten really quick. They're getting quicker every day. But as always, whenever you're doing anything with machine learning or data science, time is of the essence. Or it will be a factor, sorry. But where do we currently see synthetic data in action today? So I'm telling you about this, but is it being used in the real world right now? Actually, yes, it is. I was surprised to find out how many places are using synthetic data. Here are just a few. Automotive and robotics are using synthetic data for training robots and self-driving cars. Self-driving cars are one of the largest sectors using synthetic data, as they're creating road data and stuff and obstacles to train the models so the car doesn't, go off the road or hit something. Financial services are creating synthetic time series data to enable sharing that doesn't compromise the customer's privacy. Cybersecurity and infosec regions are using synthetic data to train machine learning models to better detect rare events, including fraud, cyber attacks. Healthcare, we're currently creating synthetic genomic data. That's a really cool blog. If you have a time to read that one, you should. To fuel medical breakthroughs and encourage better medical care by being able to synthesize a human genome. Manufacturing is using synthetic data a lot to simulate complex supply chain operations and predict when failures will happen, and more. There's so much more that's happening. And this was just the few that I was like, oh, these are really cool. I want to talk about these. It's being used everywhere. So you should really look into it. Well, what does the future of synthetic data hold, though? I'm telling you about all of this. Where do we see it going? By 2030, Gartner predicts that synthetic data will overshadow real data and AI models. It's really easy to be able to generate an unlimited amount of synthetic data, but being able to gather an unlimited amount of actual real data is actually very, very hard and expensive. We're already seeing this uptick in synthetic data happening today in the real world, where a lot of companies are looking into it. It allows for easier compliance under data protection laws such as GDPR and CCPA. So, Europe has all of these laws against, protecting data and stuff, not being able to share it because it has PII. Well, if you are able to generate synthetic data and remove the PII, then we can share the data. It also reduces the attack vector on data. If you're testing a machine learning model and you have to give your entire data science team access to the prod database, everyone who works with that database is now a target for being attacked and being a victim to maybe a phishing attack or some sort of cyber incident. But if nobody has access to the prod database and everybody just has access to synthetic data, it reduces the attack surface, the attack vectors on the database. and it makes it a lot more secure. So by not allowing more people to access real data and just giving them a synthetic data that is virtually the same thing, you're able to greatly improve your cybersecurity of your company and of your data. So how do you get started using synthetic data? Well, it's really cool. There are tons of resources available. OpenSourceAgenda.com has this great list of synthetic data. Gretel has also created this awesome synthetic data list. It's like the awesome lists you see on GitHub. So you can always go to GitHub and find the awesome synthetic data. If you want to try it out today, like you got so excited in this presentation, you want to try it out today, hey, you can try it with Gretel. All of our models are open source, so you can 100% go and download and train the model yourself. If you're using the Gretel platform, there's no code options. You can run it in the cloud or on-prem. If you want to go the open source route, you want to train this today, you have a GPU available because this will require GPUs. You can view the Gretel Synthetics repository. It's open source. There's multiple models in there right now, LSTM, GPT-3. There's a lot more to come. You can train these models yourself. You will need a GPU. So either, spin up some sort of AWS instance, or you can use the Google Colab notebooks and attach a GPU. I don't know what the billing looks like for that, so just be wary of that. But you can check it out today. You can see all of our models today at Gretel Synthetics, and you can find our docs here. However, if you don't have time or a GPU to spin up and you still want to do this, you can totally try out the Gretel platform today. All of our models, as I said, were based on open source. They're here at the Gretel Synthetics. We have a free tier. So if you want to try it out today, feel free to go ahead and try it out. Sign up for the free tier at gretel.ai. There's many different ways to run. You can literally take a CSV, drag and drop it into the console and create synthetic data from there. There's a Python SDK, and we have a lot of notebooks getting you started with all of this stuff. There's a REST API. You can find out our docs. You can find the Gretel blueprints. There's this fun with synthetic data repository that I've created where I do a lot of goofy stuff like generate song lyrics or generate synthetic cocktail recipes using like GPT-3 or something like that. So you can always go through and check that out. And yeah, there's just so much to do with it. I'm also here to say that I've got some free swag. I was able to attend PyLatam in 2019 in Puerto Vallarta, the 1 year it was in person. I'm so looking forward to if it ever gets to go back to doing that. So I miss getting stickers. So if you want some stickers, please go ahead. You can either scan this QR code or you can go to grtl.ai. That's our bit.ly short link, grtl.ai/pycon-latam-2022, and give me your email and we will reach out to you to get you some stickers. And if you want to learn more about synthetic data, go ahead and type, select yes in there, and we'll reach out to you and I'll share more resources with you. That is all I have for this time. Thank you so much for coming to my presentation today. It's been a blast. Really enjoying this virtual platform. I've done a lot of virtual conferences, and this by far has been one of my favorite ones and my best experiences with it. So you can follow me on Twitter. If you want to follow Gretel on Twitter, go ahead. You can keep up with all the things that are happening. We do tons of webinars and stuff. I do a lot more presentations. If you have questions, you can join our Slack channel. You can get started by going to Gretel, and all these slides are on my website. It's the same title on the website as it is here. I can't believe it's not real data. So yes, thank you very much. And I'm going to go ahead and scroll back through the chat and see what questions
I don't know
have.
if you can hear me now, Mason.
Raul asks, isn't at the end the model getting trained based on the same limited amount of data? Yes, this is the question that always gets asked. The model is getting trained on the data set, on the relative data set. So if you have a small data set and you're training it to generate a whole lot more, it will be representative of that original data set. So if you have like 5 records, you really can't expect, the most out of 5 records. Now you can get a lot out of 5 records, but it's going to be representative. Where it becomes really valuable, say you have 100, say you have 500, say you have 1,000. You know that this data set is representative of what you're looking for, but you just don't have enough for the machine learning model to be able to get an inference of what's going on. So then you can just generate as much as you want and send it through. So you can generate more from limited data. But the question I always get asked is like, well, what if it's a very small amount of data? Or what if the data is terribly biased? Will the synthetic data generate more of that? And the answer is yes. If the data is terribly biased, it will create what you give it. So you're still on the hook for being able to figure out, is my data actually representative of the problem that I'm solving? But maybe you couldn't even answer that question If maybe you were unable to answer because you couldn't see what the model would do because you only had 500, you don't know if it's terribly biased. But if you knew if you had 10,000 more of that data set, you would be able to. So you can even use it. You can generate synthetic data and then use it to figure out what's going on. So it unlocks multiple stages of this. Armando says he's doing classification right now. Awesome. Thank you. Smote oversampling. Awesome. Cool. Okay, we have another question in the Q&A. Fantastic. How's this approach being applied to real-time gathering generation of data for RT models? So I'm don't 100% understand the question, but I'm going to answer it the way I interpret it. So real-time data. So I'm assuming people are saying like something like maybe streaming data, like maybe you're putting something in Apache Kafka. So with synthetic data does take a while to generate. If you're doing something with streaming data and real-time streaming, you're going to have to kind of create a buffer. And I'm actually working on that code right now, not to lie. It's a sample project on the side where you're going to want to generate a ton of data and then inject it into an Apache topic or a Kafka topic, and then you would play the topic. Now, if you're talking about time series data, where you're trying to maybe you're doing something like Internet of Things, where you have sensor data, at this time, this event happened. Synthetic data 100% is able to generate synthetic time series data. And that's actually something that you can get with Gretel with one of our models, is where we are very proud of our time series data approach. So I answered both questions. I hope I hit somewhere in the right spot there in the middle. Yes. And unfortunately, I probably still won't be able to hear Katya. So we're going to play this whole... Yeah, no, still can't hear you. So we're playing this back and forth with panel chat, like where she's typing and I'm reading and answering. So I will actually, I'm going to go back there because more people are probably interested in the free swag than they are and follow me on Twitter. I know I would be. And you would get this sticker too, by the way. This I can't believe it's not real data sticker. You would get that one and a couple of other ones too. Yeah, it's a lot of fun. I think that's it. Unless there's some more questions. Thank you so much for your time. I hope to see you in person, maybe next year, maybe the year after. For those of you that are in, I will do a quick plug. For those of you that are in Mexico or something, I am the organizer for PyTexas. So if you want to follow PyTexas on Twitter and be on the lookout, maybe you want to go to another Python conference, maybe you feel you want to travel to the States, we will be having PyTexas next spring. So we would love to have you. It's going to be in Dallas, which is unfortunately farther away from you than it would have been. But if you're interested in coming to PyTexas, come to PyTexas.
All right. Perfect.
Okay, it looks like we have one more question. Class weight undersampling, is there a good advice to increase precision and recall? Unfortunately, I don't have an answer to that. I don't know. I don't have advice on that topic. I'm not terribly familiar with that topic. So unfortunately, I can't answer. But thank you for asking. Maybe someone else in the chat will be able to answer your question later. Thank you for having me, everyone.